Hello, everyone. Mr. Minix, my name. Math is my game. And today, it's Monday. And this is kind of a monumental moment. My Algebra 2A class is about to start Chapter 5. Polynomials and polynomial functions. And polynomial functions. Probably the worst part about polynomials and polynomial functions is the definition, because it scares people away. Kind of like the word integers scares people away from mathematics. They say integers and they freak out. Integers are really easy, aren't they? Polynomials is the same way. But when you see the definition of a polynomial function, you're going to freak out. A polynomial function, p of x. A polynomial function p of x is defined the following way. A polynomial function p of x is defined. I better clean that up a little bit. A polynomial function. F is for friends who do stuff together. U is for you. Gotta have the U in there. A polynomial function is defined in the following way. So we're using F notation, obviously, but P notation, P of x equals. And we got to have a beginning to this. We got to have the first term for this. And the first term is kind of a mess. It's a sub n, x to the n. So to be real clear, this is our first term. A sub n is the leading coefficient. We call it the leading coefficient because it's the first coefficient, or it's the coefficient of the first term, and it's called the leading coefficient. And it has a lot to do with what the graph of one of these things is going to look like. So the whole first term collectively, let me see if I can highlight that, just to make it more clear. A sub n x to the n, that's the first term. And A sub n is the leading coefficient. Okay. While we're at it, we might as well talk about what n is. N is the degree. And when we say degree, we're not talking about the stuff that you put under your armpit so you don't stink or sweat so much. We're talking about the largest exponent that you'll see, the largest exponent. In a minute, you're going to be asked, what's the degree of this function, of this polynomial function? And all you've got to do is look at the exponents. And the largest exponent is the degree of the function. Okay? So a sub n x to the n is the first term. Doing all right so far? Good. So then, this is where it starts to get scary. People start to lose faith. A sub n minus 1, x to the n minus 1. Well, what's its name? It's the second term. Plus a sub n minus 2, x to the n minus 2. What's its name? It doesn't necessarily have one. We use those because that's an arbitrary thing, but I want you to realize something about this. I want you to realize something about what's going on. Look at the exponents. The first term's exponent is n. The next term's exponent is n minus 1. What's going on with those exponents? Do you see? Yeah. They're decreasing. They're decreasing by 1 at a time, probably. So that's kind of important. Plus dot 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 plus a sub 2 x squared plus a sub 1 x to the first, and I am going to go ahead and put the 1 up there. And then finally, plus a sub 0 x to the 0. Now, I probably shouldn't write x to the 0, and we'll talk about that here in a second. But that's the definition of a polynomial function. People look at that and they freak out. They're like, oh my gosh, this is going to be so hard. No, it's not. The definition's the worst part of it. The definition's the worst part of it. So collectively, this whole last thing is called the constant term. Okay. A sub 0 is the constant. A sub 0 is the constant. If you remember anything at all about standard form of a quadratic equation, you remember that we had a c value on the end of it? Remember y equals mx plus b? The b in slope-intercept form? The b in slope-intercept form, the c in standard form of a quadratic were the, anybody remember what that was? The y-intercept, right? And this is our y-intercept, okay? A sub 0 is the y-intercept. A sub 0 is the y-intercept. So the graph's going to go through the point 0, comma, a sub 0. Every time I say a sub 0, it reminds me of Mortal Kombat. Sub-Zero wins. If you played Mortal Kombat, you know what I'm talking about. Okay, so backing up then, a sub 1 x to the first. This has this very special name. Very special name, and it starts with L, and it's not Larry, and it's not Lonnie, and it's not LaRue, and it's not Leroy. It's linear. It's our linear. It's our linear. It's our linear term. Okay? And by all rights, we probably don't need to put the exponent of 1 on the linear term, because this is varsity math, son. Backing back to my constant term, I probably shouldn't even write times x to the 0 power. Probably shouldn't even write that. Okay, but it brings up an argument, and we'll see that in a minute. So backing up one more time, over here, a sub 2x squared. We know what that's called, right? That's called our quadratic term. That's our quadratic term. So hopefully you get the idea what these polynomials are. In chapter 2, we didn't study much of chapter 2, but in algebra 1, you studied lines. And they had a degree of 1. And in chapter 4, we studied quadratics, and they had a degree of 2. When we study polynomials, it's just going to have a bigger degree, that's all. We might still study lines. We might still study quadratics, and you're going to have to remember all the stuff that you knew about lines and quadratics before now. I really wish I had my microphone cable with me today. I don't. But if you could picture a cable or a wire stretched end to end, continuous with no breaks, holes, or jumps in it. That's what a continuous function means, and you'll study those at pre-calculus. There's no holes, there's no breaks, there's no jumps in it. It's just, you know, a string of wire from end to end. That's what polynomials look like. That's what they look like. Some polynomials go like that. Some polynomials turn around once. Some polynomials turn around a couple of times. Some polynomials turn around several times. Some of them look like W's. Some of them look like M's. But all they are is like a rope with no holes, no breaks, no jumps in it. How are we doing so far? Good. Okay. So let's go back and dial in some things and talk about what A has to be and what N has to be. Okay, so we defined a polynomial function A sub I. And when I say sub I just mean an arbitrarily chosen A value. So it might be my leading coefficient, it might be my constant, but A sub I must be a real number. So what I'm trying to say is all the coefficients, whether it's a coefficient of a quadratic term, whether it's a coefficient of a 15th degree term, the coefficients have to be real numbers. Whether it's the constant, it has to be a real number. It could be pi, it could be irrational, but it has to be real. Now, n must be a natural number. And here's where I don't understand what textbooks are trying to say. They're saying that n, our degree, our power, our exponent has to be a natural number, right? Let's think about where the natural numbers start their life. What's the very first natural number? The first natural number is 1, isn't it? So let's go back up to this for a minute. It says n has to be a natural number. Okay? So n is our power. And we saw earlier that for our linear term, the power is definitely 1, right? What's the power on our constant term? 0. And 0 isn't natural. There is a built-in, what's that word called when something opposes something else in geometry? A contradiction. There's a contradiction built into the definition of polynomials. Every single textbook prints it, and nobody's ever called them out on that. I don't get it. They use n because n usually means natural numbers. What I'm getting at is times x to the 0. 0 isn't a natural number. So maybe everybody who's ever written a textbook and says that this is the definition of a polynomial function for all natural numbers n, maybe they overlooked that. Anyway, any questions so far? Okay, so let's make a table. Nice big table. Polynomial. We're going to put some polynomials in here. We'll write their degree. We'll write their name by degree. Going to need a couple more columns. Number of terms. Number of terms. Number of terms. And finally, their name by number of terms. When people are named, oftentimes boys are named after their dad. Oftentimes girls are named after their aunts or aunts, however you say it. What if you're named after the family dog? Is that an insult or is that a compliment? What if your cousins name their dog after you? Is that a compliment or an insult? Anyway, so let's just look at some polynomials. Now, I might not necessarily have a polynomial function, and I want you to realize that sometimes we have expressions and sometimes we have functions. I'm just going to throw a polynomial out, something like x. That's it, just x. How many terms does that have? It's got one term. So that just has one term. What do you call a bicycle with one wheel? A unicycle, or some people actually call it a monocycle. And so a polynomial with one term is called a monomial. I like to say the meal is meal, like you're eating it. It's a monomial. It's a meal that you don't want to kiss, or you may catch it also. A monomial. Okay, so if there's just one term, we call it a monomial. This particular one happens to have a degree equal to how much? What's the degree here? The degree is 1. And if the polynomial has a degree of 1, we give it a name of, it starts with L, linear. We say it's linear. So when you name polynomials, usually the way it's named, usually the common way to go about it is to name it by degree and then by number of terms. So we would call this a linear monomial. If we had to look at this polynomial x, we would say x is a linear monomial. Let's look at another one. Let's look at something like negative pi x squared. And that's it, negative pi x squared. So what's the degree of that one? The degree is 2. And the name, because the degree is 2, is what we studied all chapter 4. Quadratic. Quadratic. How many terms does that have? Terms are separated by the operator of addition. There's one term. There's one term. And this is still a monomial. Still a monomial. The leading coefficient's negative pi. Is pi real? Pi's real. That's cool. That's a polynomial. We're good. We're good. Ain't nothing wrong with that. Let's look at another one. 3 minus 5x to the third power. What's the degree of this one? The degree is 3. The degree is 3. Because the degree is 3, what's its name by its degree? Cube, and we put the ick on the end of it. We always like to put the ick on the end of it, so it's cubic, we say. It's cubic. How many terms does this one have? Terms are separated by the operator of addition, and subtraction is addition of the opposite. So there's 2 terms here, and a bicycle falls over because it's too tired. And binomials have 2 terms. Binomials have 2 terms. Okay. All right. There's one that I probably should have inserted into the table if I could. I hate putting it this far down, but I'll go ahead and do it. We had a nice thing going. What if we just had rad 7? Is rad 7 real? It is. It's irrational, but it's still real. What's the degree of this? The degree's not 1. If the degree was 1, we'd have an x in it. The degree's not 2. If the degree was 2, we'd have an x squared in it. The degree here is 0. And the name by degree is constant. And how many terms does this have? 1 term, and we call it a monomial. If I'm being perfectly honest with you, I would make a strong argument that constant monomials are not even polynomials by definition. They're not very exciting. It's just a horizontal line. And polynomials are rope-like things that go from end to end, and sometimes they turn around and sometimes they don't. So anyway, but if you ever encounter one of those, I would argue that it's not even a polynomial to begin with. So let's look at something like this. Let's look at something like 4x squared minus 6x squared plus 7x plus 4x. What's the degree there? Well, the degree is not 6. The degree is just the biggest exponent that shows up. So the degree is 2. So what's the name by degree? Quadratic. Good. Quadratic. How many terms does this polynomial have? Yeah. It looks like it has 4 terms, but it actually doesn't. It doesn't have 3. It's just got 2. It's just got 2. So maybe we probably ought to spend a minute and talk about how polynomials should be written. So the name, because it has 2 terms, is a binomial. So what we need to talk about and address before we go any further is what it means for a polynomial to be in standard form. Standard form. In standard form, what we do is we combine like terms. Combine like terms and write the terms in descending order. I know the C's silent, but in descending order. Anytime you're working with a polynomial, it's advisable, it's prudent, it's the right thing to do to put it into standard form. Combine any like terms and write the terms in descending order by, I almost left out the most important part, by degree. And if you go back to the definition of a polynomial, what a polynomial function is, remember the first exponent was n, and the next one was n minus 1, and the next one was n minus 2, and so on. Does that make sense? Cool. How are we doing so far with this polynomial business? Do we get it? Okay. Well, I really can't wait till we get a little bit further along in our table. It's going to be so good. So we saw a linear, we saw a constant, we saw a cubic. I guess we better go to something that has an exponent of 4 in it. Maybe it's something like 3,655.2 x to the 4th plus x cubed plus x squared. There we go. So what's the degree is 4? Does anybody know the name of this? It's really hard to pronounce. It's a very guttural sound. Anybody know it? Has anyone ever gone to the store and bought some milk? They used to sell milk in quarts. Can you still buy a quart of milk? Anyway, there's 4 quarts in a gallon, right? When the degree's 4, it's called quart. Ick. Remember, we put the ick on the end. Quartic. Some people say quartic. If you take physics, you'll learn about quarks. So anyway, quartic. Q-U-A-R-T-I-C. 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 How many terms does this thing have? Tres. Tres. And a polynomial that has 3 terms is called a trinomial. A trinomial. Awesome. Awesome. Cool. So let's go with x to the 5th plus x to the 4th plus x cubed plus x squared plus x plus 1. When you get to calculus and you have to find a derivative, you're going to like it when you have a polynomial like that. So what's the degree here? 5. Bob Dylan wrote a song. I can't rehash the song because it's got some inappropriate lyrics. But he wrote a song about Quinn the Eskimo. And I always think of that when I think of this one. So Quint. If a woman gave birth to 5 babies all at once, they would say that she had quints. So this is quintic. Quintic. How many terms does this thing have? It has 6. And a polynomial that has 1 term is a monomial, 2 terms is a binomial, 3 terms is a trinomial. That's all the more names you get other than this one. Anytime it's more than 3, we just call it a polynomial, okay? Some people want to say it's a quadrinomial. No, don't worry about that. It's a quintrinomial. No, don't worry about that. Anytime there's more than 3 terms, it's a polynomial. And as a matter of fact, I got to be perfectly honest with you. There's a trick question on your midterm exam. You want to see it? Okay. A, B, C, D. X squared plus 5x plus 2. X to the 5th minus 4x plus 1. X squared plus 3. Negative 11x cubed. Which is a cubic polynomial. And people get so hung up on the polynomial that they think, well, polynomial, that means it's got to have a bunch of terms. Maybe choice B should have had more terms in it. So they're looking for something that's got a lot of terms because poly means many. But wait a minute. Let's go back to the title of the section. The title of this section is Polynomials and Polynomial Functions, right? And then when we look at this table, some polynomials only have 1 term. And if we're naming it because it only has 1 term, we're supposed to call it a monomial. But a monomial is still a polynomial in general. Does that make sense? I'll say that again. A monomial or a binomial or a trinomial, even though they have special names because of how many terms they have, they're still polynomials. So what's the right answer to this question? D. And you're thinking to yourself, well, it's not a polynomial. Yeah, it is a polynomial. It's a monomial, but they're trying to trick you. They're trying to make you look for something that has many terms. And just because they say polynomial doesn't necessarily imply that it has to have more than 3 terms. The key word here is cubic. You're looking for the one that's cubic, right? Even though it's a monomial, it's still a polynomial. Even though you're 15, you're still a human being. Even though you're abducted by aliens and taken to the planet Zoltar, you're still an Earthling. Anyway, so let's keep on trucking. I love this. I love polynomials. They're great. Polynomials are awesome. So keep in mind, anytime it's 3 or more, it's a polynomial. So let's go x to the 6th. The degree obviously 6. Does anybody think they know the name of a 6th degree polynomial? European Vacation had a little quip on this. You might think that this is sextic, right? However, if you thought that was sextic, the next to the 7th would be 7th, and that would be septic, and that would stink. So the deal is, anytime it's 6 or higher, what we just call them is nth degree, and make sure you plug n in. Okay. So for instance, we would just call this one a 6th degree. Okay. If it were 7, it would be a 7th degree. Does that make sense? So we don't have any more names beyond quintic. Some textbooks don't even require you to memorize quintic. I do. I expect you to know quintic. So 6 is not sextic and 7th's not septic, because that would stink. Doing all right? Okay. So, example 1. Name each. Do, 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 do. Okay, name each. So number 1A, when you name each, remember, name by degree, and then special name by how many terms. Name by degree, and special name by how many terms. So what will we call number 1, part A? Yeah. Quadratic trinomial, perfect, nice job, you got it. Quadratic trinomial. It's a quadratic trinomial. What do we think about number B? Yes. Perfect. 9th degree monomial. Awesome. 9th degree monomial. And the last one, t of x equals negative 9x plus 6x cubed. Yeah. Cubic binomial. Good. Cubic binomial. They say that you could tell a lot about somebody by their name. I better not get too far off topic because we got a lot of ground to cover. But I will say that I'm kind of excited about what my name means. For those of you that don't know, my first name is that. That's my first name. I can't say anything else. So anyway, I can't say it means something in Hebrew, but I can't say what it means. So, all right. So we need to talk about end behavior. I mentioned earlier about a polynomial being a rope. And sometimes these ropes go like this. Whoop. And when we talk about the end behavior of a polynomial, what we're talking about is what's going on the ends. What's going on the left end? What's going on the right end? For sake of time, I'm going to give you the elementary language of this. When you get to pre-calculus, Mr. Englehart's going to expect you to know the varsity math son language associated with these. Okay? So on the left, what's happening is, on the left side, what's happening is this one is heading downward. Okay? To be clear, when it's heading downward, it's approaching negative infinity. Okay? Downward really means negative infinity. Okay? And that's the kind of language that Mr. Englehart's going to expect you to use is the negative infinity. And on the right side of this one, this one looks like it's heading up or toward positive infinity, right? So up is positive infinity, down is negative infinity. And on the left, what we mean, and this is kind of weird, when we say on the left, what we're talking about is as x approaches negative infinity. That's the language that Mr. Englehart's going to want you to understand. As x approaches negative infinity is the same thing as saying on the left side. As x approaches negative infinity, that's the same thing as saying on the left side of this graph. So on the right side of this graph, we'd have to say as x approaches positive infinity. Okay, so saying the right side of it is the same thing as saying as x approaches a positive infinity. And technically, when we say down, what we're saying is p of x is approaching negative infinity, and we go up, p of x is approaching positive infinity. So in pre-calculus, you're going to have a lot more words than I'm going to show you. Okay, but for sake of time and simplicity, we'll just talk about things being down and up. So 2 words, down and up. Reminds me of 9th grade gym class. I hated 9th grade gym class. Do you guys know Lauren Jones? I'll give a shout out to Lauren Jones. Her grandpa, Richard Stoneman, was my gym teacher in 9th grade. He was a mean man. Down, up, down, up. Never forget 9th grade gym class. So anyway, with end behavior, there's basically 4 different scenarios that we can think of. There's 4 different scenarios that we can think of. 4 different scenarios that we could think of within behavior. So suppose a polynomial does this, whoop, and who knows how many twists and turns it takes in the middle, and it really doesn't matter. And suppose a polynomial does this, whoop, and you know, might just do this once, it doesn't really matter. But what we care about is what's going on the ends, on the ends. What we care about is what's going on the ends. What's going on the ends. So 4 different situations. Now, here's where people get lost. So if you need to take a deep breath, take a deep breath. If you need to recut your bearings, recut your bearings. If you missed the joke, I said that bicycles fall over because they're too tired. If you're ready for Christmas time, you can start thinking about some Christmas jokes. I already told the one about Darth Vader and Luke Skywalker, didn't I? Darth Vader says to Luke, Luke, I know what you're getting for Christmas. I felt your presence. So what I like to call this particular end behavior situation here is up, up. This next one I like to call it down, down. And when you get to pre-calculus, Mr. Englehart won't let you use up, up, and down, down, but you'll hopefully be able to apply the same principles. The one in the bottom right is what I like to think of. I had on my shirt yesterday, some up dog. And then the one on down here is down and up, and down and up. Anybody else have up dog on their shirt? It's really hard to get out. Even when you run it through the wash, it doesn't come out. So, stains very bad. Stains very, very bad. So, the best bit of advice I can give you is think about y equals x and y equals x squared when you're trying to picture these. If we think about y equals x for a minute, we know that it's a line that goes like this, right? And the end behavior of a line could be down up or up dog, right? What we need to know, though, is two components of these. We need to know two components whenever we talk about end behavior. And those two components, when we talk about end behavior, that we need to consider are the degree, and the leading coefficients sign, So whenever you try to find the end behavior, as long as you know the leading coefficients sign and the degree, it doesn't matter what terms come after that stuff. The only thing that indicates the end behavior is the degree and the leading coefficients sign. So let's think about a line that's going uphill. What's the slope of that line? Positive. And the slope is the leading coefficient, isn't it? So if the leading coefficient is positive, we would have a line that goes down and then up. If we had a line that goes up and then dog, then that's going to be a leading coefficient that's negative. Now, some people a lot more observant than me noticed one time, wait a minute. The leading coefficient's positive, it's going up on the right. The leading coefficient's negative, it's going down on the right. Is that always going to be the case? Yes. You might want to make a note to self about this. The leading coefficient tells you what the graph does on the right. Leading coefficient tells about the right side. Positive means it's going up, negative means it's going down. But that's just on the right side. And then you think, well, how do you know what it's doing on the other side? Well, let's go back to the earlier advice I gave you. I said, let's think about x and let's think about x squared. If we think about x squared, we're thinking about parabolas, right? Hey, wait a minute, the leading coefficient, it's positive. And it's going up on the right, imagine that. Hey, another parabola, it's going down and down. What's the leading coefficient? Negative. So if it's leading coefficient's negative, it's going down on the right. Positive, it's going up on the right. But what about this whole thing if it's up and up or up and dog? How can you keep that straight based on the degree? Well, let's compare the degree of a line to the degree of a parabola. I don't know if you've ever graphed a fourth degree polynomial. If you haven't, I'll show you what they look like. They're awesome. They just look like SpongeBob SquarePants in the middle. Love this calculator. So if we graph x squared, we've seen that, right? It's a parabola, nice U shape. Let's make it x to the fourth. All that's going to happen is it's going to square off in the middle. Let's make it x to the 10th. I said x to the 10th. It's going to look like SpongeBob SquarePants. It's going to look like a rectangle. Do you see what's going on there? So what can you say about the degrees then with the case of up and up and down and down? What do you know about the degrees? They're going to be, I know it's Monday. You can do this. You say I can't even, but you can even. They're what? They're even. Even Steven. So the degree is even. The degree is even. If the degree is even, the graph's going to do the same thing on both sides. What's the contrapos or the what's the counter statement to that? If the degree is odd, that's going to do the opposite things on the ends. If the degree is odd, it's going to do the opposite things on the ends. So you might want to make a note to yourself about that. If the degree is odd, then it's going to do opposite things on the ends. Does that make sense? I hope. So like I said, this is the part that confuses many people. If you get it, you're going to get it right off the bat. If you don't, it's going to go right over your head. You're going to feel like crying tonight. You're going to be like, oh, it's so stupid. I hate algebra. It sucks. It's the worst. Polynomials are awful. So here's a chance to practice. You'll get another chance in the homework. Example. Describe the EB of each. Number A, number B, number C, number D, number E, number F, number G, number H. We'll do a whole bunch of these. 6 plus 5x. 4 minus 3x squared plus 7x to the 8th. 9x to the 5th plus 4x to the 2nd minus 16x to the 3rd minus 2x to the, let me make that minus 21x to the 6th. There we go. 4x to the 5th. Negative x squared. Negative 6x to the 9th plus 5. 11x to the 10th. Negative 16x to the 17th power. That'll be enough. What's imperative? Yeah, we got a question? End behavior, I'm sorry. EB is end behavior. I'm sorry, I used too many abbreviations. We're going to describe the end behavior of each of these. Describe the end behavior of each. That's supposed to be an EA dot. My high school English teacher had it right. He said, thou, not thous. He said, thou shall not abbrev. He was right. Someday, but not today, I'll have to show you about my abbreviation about that. I can't do that on camera. All right, so we got 6 plus 5x. So what you need to realize is we're after the leading coefficient, and we're after the degree. So the 6 is irrelevant in number A. All we're looking at is plus 5x. That's gonna steer the ship here. What's the degree? 1, and we got to ask ourselves, is 1 even or odd? 1's odd, so is this thing going to do the same thing on the ends or the opposite things on the ends? The opposite thing. So it's either going to be up dog or dog up, down up, right? So now we got to think, okay, what's the leading coefficient, positive or negative? Positive. Positive tells us it's going to do what on the what? Up on the right. So on the right, it's going to be heading up, and on the left, then it's going to do the opposite thing. So on the, so it's going to be down up. You got him. You got him. So it's going to be down up. And I'm just going to use these little arrows for the sake of space, down and up. Okay? Let's try number B. What term steers the ship in number B? 7x to the 8th, right? So the degree is even, so it's going to do the same thing on the ends. The leading coefficient is positive, so the end behavior here is going to be up and up. Cool. What term steers the ship in number C? Negative 21x to the 6th. Anybody think they got the end behavior here on lock? They got it figured out? Down and down. Down and down. What about number D? Down and up. Down and up. What about number E? Down and down. Number F? Up dog. Everybody's got some up dog on their shirt. Number G? G? Up and up. And number H? It's odd, so we're not going to do the same thing on the ends. We're going to do the opposite things on the ends. It's negative. It's going to be going down on the right, right? Down on the right. So this one's up dog, right? Unfortunately, I don't have time to talk about finite differences today, so we'll have to resume this on tomorrow. It's been real. It's been fun. I hope it's been educational. I hope everybody has the best Monday they've ever had. I'd like to give a shout out to the future Mr. Minnick for being such an awesome guy.